In the last class, we have seen about electric potential energy. In this class, we will see what is electric potential. Electric potential. How can we define electric potential? Electric potential is defined as potential energy per unit charge. Electric potential, and it is denoted by V, is given by potential energy per unit charge. So V is equal to potential energy is denoted by U divided by Q dash, or potential energy U is equal to Q dash into V. The SI unit of V is SI unit of electric potential is volts or joules per coulomb, because it is energy divided by charge. Now in the last class, when we did electric potential energy, we have considered a system of two charges, Q and Q dash. We said the Q is fixed at point P and Q dash is moved from one place to another. So we took those 2 points as R and S. Let me draw the same figure whatever we have discussed in the last class. You may please refer to the last class notes. So PR, yes, and we took the distance between P and R as R1 and P and S as R2. We have calculated the electric potential energy is the work done in moving the charge from R to S. So the work done in moving the charge Q dash from R to S, we got it as work done in moving Q dash from R1 to R2, not from R1 through R1 to R2. So I can write from point R to S is W is equal to Q into Q dash divided by 4 pi epsilon naught into R1 minus Q into Q dash divided by 4 pi epsilon naught into R2. And then we wrote it as W is U of R1 minus U of R2, that is potential energy at R1 minus potential energy at R2. U of R1 minus U of R2. Now divide both the sides by Q dash. Test as Q dash. So W divided by Q dash is equal to U of R1 divided by Q dash minus U of R2 divided by Q dash. And we know U of R1 by Q dash is, by our definition, the potential energy per charge is electric potential. This is equal to V of R1 minus V of R2, where V of R1 is the potential energy per unit charge at point R and V of R2 is potential energy per unit charge at point S, where V of R1 equal to U of R1 divided by Q, which is nothing but potential energy per unit charge at R. Similarly, V of R2 is V of R2 U of R2 divided by Q dash, which is also potential energy per unit charge at S. Now suppose if the this V of R1 and V of R2 are potential at points R and S respectively. So we can write V of R1 and V of R2 are electric potentials at points R and S respectively. So now if point S is infinity, if point S is at infinity, then W by Q dash is equal to V of R1 minus V of infinity, and the potential energy at infinity is 0. PE at infinity is 0. So this, potential energy by unit charge, so this also becomes 0. Therefore W by Q dash is equal to V of R1, or I can define V of R1 equal to W by Q dash. So with this equation one can define the electric potential. The electric potential at any point is the work done in bringing a unit positive charge from infinity to that point. So if Q dash is equal to 1, then V of R1 will become equal to W. So it is the work done in bringing a unit positive charge from infinity to that point against the electrostatic forces without any acceleration. So unit positive charge, if Q dash is equal to 1, then V of R1 equal to W. If Q dash equal to 1, then V of R1 is equal to W. That is electric potential at any point. You can define, I will write here. For a unit positive charge, for Q dash is equal to 1, V of R1 coulomb, V of R1 equal to W. So the electric potential is equal to the work done. Therefore electric potential can be defined as the electric potential at any point in the region of electric field is equal to the is equal to the amount of work done in bringing the unit positive charge from infinity to that point, because we took v of that R2 equal to infinity, so v of infinity, u of infinity is 0. So that is how we got this equation. So it is the work done in bringing unit positive charge from infinity to that point against the electrostatic forces, because in the region of electric field there will be electrostatic forces without acceleration. The electric potential at any point in the region of electric field is equal to the amount of work done in bringing the unit positive charge from infinity to that point against the electrostatic force without acceleration. So electric potential is work done by charge, and the unit of potential is equal to volts, which is also equal to joules per coulomb.